So let's say the foil was a perfect rectangle, as I have beautifully drawn here. And let's say that the width was 5.15 centimeters and the length was 6.25 centimeters. And let's say that the mass was 0.329 grams. All right. Now, you have data like this, but different because your data comes from the video. I have just made up this data, right? So this is a piece of foil, aluminum foil. Now, given in this problem is that the density of the aluminum foil is 2.70 grams per milliliter. Now, in a previous assignment, you learned that 1 milliliter is the same as 1 cubic centimeter. So let me just write this as 2.70 grams per cubic centimeter. What does that mean? That means that it is really 2.70 grams for every 1 cubic centimeter. Okay? Cubic centimeters, huh? You know, I have some centimeters here. I don't have enough to make a cubic centimeter, but because I have centimeters here, maybe I should use the volume of this piece of foil. Now, the piece of foil is a rectangular block. You know, it is a block with some thickness, as I am beautifully drawing here. You see this thickness there? The thickness is very, very thin, actually. So we don't usually think of aluminum foil as a rectangular block, but you could think of it as a rectangular block. And the volume of a rectangular block is length times width times height. Instead of height, I'm going to call this thickness, right? Length times width times thickness. So this was the, I'm just going to say this is the length and this is the width. It doesn't, I forgot if I called this the length or this the width, it doesn't matter. So what I want to know is, what is T? Do I know the length? Yes, right there. Do I know the width? Yes, right there. Do I know the volume? Not really, but, you know, density is equal to mass over volume. So I can get the volume, you know what I mean? So let me multiply volume on both sides and divide both sides by density. In other words, do algebraic magic on this, and I get volume equals mass over density. Volume equals mass over density. So that means wherever I see volume, I can just put in mass over density instead. Where do I see volume? Oh, there's volume. I'm just going to put mass over density instead right there, okay? So here I go. Mass over density equals LWT. Do I know the mass? Why, yes, it's right there. I know the mass. Do I know the density? Why, yes, it's right there. I know the density. So mass over density equals LW. Do I know L? Yes. Do I know W? Yes. Now I just have to know T. So I'm going to solve this equation for T. I'm going to do it a little more neatly down here. So mass over density equals length width T. I'm going to solve this for T by dividing both sides by length width. Length width goes in the bottom, right? So now we have mass over length width density equals T. All right, so that's great. Now I'm going to put numbers in here. So what was the mass? 0.329. That's mine. You have your own mass from the video. Length was 625, width was 515. Density was, okay, I'm going to call this cubic centimeters so that you could see what I'm doing here. Okay, now, am I going to end up with the right answer? The right answer has to be in centimeters. Am I going to end up with centimeters? Let's see. Grams cancels with grams. I have 2 centimeters, which makes centimeters squared, and I have 3 centimeters. So 2 centimeters will get rid of 2 of these, so I'll have 1 centimeter left. Now this centimeter is under a fraction bar, but this fraction bar is also under another fraction bar. So something under a fraction bar means the reciprocal, and the reciprocal of something over centimeters is just centimeters on top, because reciprocal means flip. So what I'm trying to say is the fraction of a fraction goes on top. So under fraction bar goes on top. So denominator of the denominator goes on top. So yes, I get centimeters. So I am going to have the right answer here. So let's see what the answer is. It should be a ridiculously low number. Oh, here we go. Nice calculator. Because, you know, aluminum foil is thin, like really thin, like really, really thin. Oh, yeah, that's a ridiculously low number. So I've got, what about the significant figures? This is a division problem, and I have 3 significant figures on all these guys, so 0.00379er. Centimeters. Or I could say 0.379 times 10 to the power of -3, right? So I'm going to type that into the canvas, because I want that to be the answer. Thank you, bye. Oh, it's not your answer, that's my answer. You have to calculate your own answer, or do it with your friend, you know what I'm saying? Yeah.